Hello everyone, this is just a short news update wrap-up on the latest Falcon 9 launch. Yesterday, SpaceX launched a Falcon 9 rocket carrying the Spanish PAZ radar Earth imaging satellite for commercial, public and environmental purposes into a Sun-synchronous polar low Earth orbit on a previously flown Falcon 9 booster that had previously launched a Farmersat satellite. Now, a Sun-synchronous orbit is a low-altitude polar orbit, so you go basically north-south around the Earth between the poles. But it's specifically one designed so that the tidal forces from the Earth's rotation as well as the Sun change the orbital plane and rotate it 360 degrees once a year, so the orbital plane in relation to the Sun basically stays the same. The satellite is essentially always on the day-night separation line and always in the morning or evening time, and so it can image everything in the same lighting conditions. It has constant sunlight. It's a very practical orbit for low altitude Earth observation satellites. The first stage was not recovered for reuse this time, as it was already an outdated first stage and they didn't want to bother with setting up the drone ship and carrying extra fuel. However, two interesting things were on this flight directly related to SpaceX which are new. For once, they have for the first time tried to recover the fairings, the aerodynamic cover around the satellites at the nose, which aren't really that big a part of the rocket, but they're another step towards full reusability, and they're still pretty expensive. And while second stage reusability has basically been stopped in development to focus on the BFR development, this is still a good improvement for the Falcon 9. Now, this test was not entirely successful, but it was already in the right direction. They did use the catching net ship that had been seen previously, this ship with this weird claw construction on top that SpaceX had ordered, and that actually spans a catching net for a soft landing, not in the water so that the salt water doesn't corrode or damage the fairing, and the fairing itself uses a parachute or a gliding chute. Now, these aren't perfectly accurate words, but to get the idea across, it could be commonly described as paragliding. It's not one of the typical round parachutes where you have very little control, but one of the basically round blow-up wings that you can control and glide down on. Now, the fairing, while it's not really designed as a lifting body, has of course a huge surface area to mass ratio, so it can basically glide through a re-entry with relatively little heating for its speed, and with quite a bit of control. It uses tiny thrusters to adjust its attitude, and then eventually deploys a tiny drag chute and a glide chute to control its descent onto the catcher ship. Now, in this first attempt, it actually missed by a few hundred meters, which is very, very little for spaceflight measures. It also still landed softly in the water. Now, it might be slightly damaged, but it's not destroyed. It has been recovered and will be further examined. And given this is SpaceX, a few funny images, of course, showed up on the internet. Then the second interesting thing was that there were two experimental satellites riding along on the rocket. PAZ was still the main mission goal, but these were also deployed into a similar orbit, and they are actually SpaceX's own satellites. They are technology demonstrators for the huge fleet of many small, not tiny, but more smallish communication satellites SpaceX had been planning to send up for quite a while into a relatively low orbit, bringing relatively low lag and high bandwidth satellite internet to areas with little or no internet coverage. Now, this is of course not active yet. It's far from complete. Not only is the fleet planned to become the biggest satellite fleet ever with several thousand satellites, but also these satellites themselves are still technology demonstrators. They are basically working, but there may still be improvements needed. However, they are technically working, and they may eventually serve as a small part of the fleet once it is actually complete. They are already capable of some test signal sending, so there will be further updates coming on the test status of these satellites. The two satellites had been successfully deployed from a cylinder-shaped multi-satellite launch adapter, in this case built for the combination of PAZ and these two satellites. Of course, when they only launch this type of satellite, they'll probably launch much more than two, because in this case PAZ was still the heavier part of the payload, and that adapter would have to change for this and become longer and might carry 4 or 8 satellites at once. The first test satellites were named Tintin A and Tintin B, probably after the classic comic series hinting at the moon rocket arc, which, despite being just a tiny part, has kind of become a classic sci-fi story in and of itself. After the successful satellite separation, Elon Musk jokingly tweeted that the Wi-Fi password was Martians and that we're not supposed to tell anyone. From then it did take a while until the satellites would be in an area where they could be reached with the current infrastructure again. This is the first tiny part of a giant fleet that isn't complete yet, so currently they're actually pretty hard to reach, as each satellite only covers a relatively small moving area that moves around the Earth while the Earth rotates underneath it. Now, with many satellites, this would build a very reliable network with a lot of overlap and bandwidth, and since it flies lower than a geostationary satellite with a very little lag and light speed delay. But as long as the fleet only consists of 2 demonstrator prototypes, this means that you can actually only reach them roughly once a day as the Earth rotates along underneath their orbit and they pass over you. By now first signal tests should have begun, but there still hasn't been any release, and that is probably going to take until tests are further progressed. So we're still waiting for updates, but if this is successful, then we can expect some pretty interesting stuff from SpaceX in the future, launching the biggest satellite constellation ever. Now, this was just a short news update, so I'm not going to go further into detail. I might later talk more in detail about the planned Starlink constellation and the technologies needed to make it properly feasible and useful and reliable. And I will also update you on any upcoming rocket technologies like fairing reusability and explain the theory and physics behind spaceflight in general. If you have any questions about aerospace engineering, spaceflight and the physics and mathematics behind it, I will always try to answer them, and as always, thanks for watching.